Welcome to lesson 22, problem number 1, where we are simplifying rational expressions. So you might remember that we did something like this in an earlier lesson where we learned all the exponent rules. So we are really reinforcing it before we move on to some more complicated rational expressions. So this first part may seem a little bit like a review, and that's because it's such an important concept. We want to make sure you have it down really, really, really well. So let's get going. And by the way, if you forgot any rules of exponents, feel free to look in the back of this workbook for all the rules laid out for you. Okay, let's get started with this first one. And what we have is 7 over 21. So that becomes 1 over 3. And by the way, no negative exponents in our final answer. So when we do 2 minus 7, you're going to get j to the negative 5. But wait, 2 minus 7 is negative 5. We don't like negative exponents in our final answer. So we're going to do it. We're going to rewrite it and make it 1 over. We leave the 3 down there. We leave the 1 in the numerator. And the j to the negative 5 gets put on the other side of the fraction line, and it becomes j to the positive 5. And keep in mind, let's just kind of make that a little bit neater there. Keep in mind that the fraction line is an exponent sign changer. So lots of rules we just reviewed in one problem. Let's look at the next one. 8 over 4 becomes 2. X to the 5th over x to the 7th becomes 5 minus 7, so it's x to the negative 2nd. There's really a 1 here, so it's y to the 1 minus a negative 9. So 1 minus, I'm just going to write it up here, minus a negative 9 becomes 1 plus 9, or y to the 10th. So the only part of this expression that has to go into the denominator for our final answer is the x, because that is the only thing being raised to a negative exponent. The numerator stays with 2y to the 10th, and the denominator becomes x to the positive 2. Okay, remember that we can multiply and divide as well with these rational expressions. And really, because it's multiplication, we're just multiplying all this together and all this together. So if it starts in the numerator of either fraction, it's part of the numerator. If it starts in the denominator of either fraction, it's in the denominator. Now, when we simplify, some things may change, but here we go. I'm going to start by just multiplying right across to make sure you see exactly what I mean. So I'm going to say it's 6a squared b squared. Okay, that's our numerator. Our denominator, on the other hand, is going to be a to the 4th, b to the 6th. Okay, now we can simplify. So the 6, I'm going to change the color. The 6 can stay in the numerator. There's nothing to simplify it with. A to the 2nd over a to the 4th is a to the negative 2. But if you see it okay, I'm going to just move it down to the denominator and make it a to the positive 2. So I'm kind of doing 2 steps at once there, but if you're not sure about that, again, email me. All right, we have b to the 2nd over b to the 6th. 2 minus 6 is negative 4, so you could write it as b to the negative 4 up here, but I'm going to challenge you to just go directly to making it b to the positive 4 in the denominator. Okay, so that's everything we can do. It's as simplified as possible. Let's look at the next one. So for this last one, I'm going to start by rewriting it as a multiplication problem, because it's really, we keep the first fraction, we change the division symbol to multiplication, and then we flip that second fraction, which means basically taking the reciprocal of it. So it's keep, change, flip. Let's do it just to make sure you remember that with dividing. Okay, sorry, this should still be circled. Okay, so we have 5x to the negative 1 over y to the 3rd, and I'm going to take the liberty of not writing that z to the 0, because anything to the 0 is 1, so we don't need that. So we changed, and now we are flipping. So this is now a multiplication problem. Okay, so now let's take the 5 in the numerator. Remember that it's okay to cross cancel. Over the 10 becomes 1 over 2, because I'm going to now write it as one fraction. So 1 over 2. Okay, the y to the 3rd down here is going to get combined with this y to the negative 3rd, because that's going to be brought down and changed to a positive 3. So what you have in the denominator is y to the positive 6. If you're not sure about that, the other thing you could have done is you could have said -3 minus 3 is -6, but that would have been a y to the -6 up in the numerator, which is the same as y to the +6 in the denominator. Okay, so we're done with the y's, and now this x to the -1 is going to go down, get combined with the x in the denominator, and become x squared. So our final answer is 1 over 2 y to the 6th x squared. Great job on that reinforcement. Okay, we'll see you next time.